Okay guys, I'm in the office today and I've been an idiot. I've done this learning timetable for you before, and actually I've made a mistake on the last one, on the graph on the last one, so I'm just going to go through this one again. Okay, so I can sort of leave the question up. So Sunday's question, there it is. So this is the Edexcel one. I'll just fold it round. There it is. Okay, so there we go. We're on learning timetable number 4. And it's this one here. Okay, so it's a car is moving along. There you go, you can see the question. Oh yes, we're in business. So a car is moving along the horizontal road at time t is 0. The car passes point A with a speed of 25 meters per second. So we've got to sketch a speed time graph. My speed I'm going to put as v for velocity. Time starts at 25 there, so that's where it is at t is 0. T is equal to 0. Okay, and then the car does for 10 seconds for that speed. Okay, so there's 10 seconds there. We'll label that one 10. Okay, the car decelerates for 8 seconds. So at that point, so that's 18. And then it carries on the speed until it reaches 30. So it carries on with that constant velocity to 30. And that's part A done. We've sketched it. So 10 seconds at 25, decelerates, so a straight line because it's constant deceleration at the point of 18 seconds. So it does that for 8 seconds, between 10 and 18. And then a straight line here. You know, on the exam, again, I know I've done it, I'm working on a whiteboard, but on the exam, you know, use a pencil and ruler for that. Mine's a little bit rubbish. Okay, but make sure yours nice straight sort of pencil lines and so on. Okay, so that's part A. Part B, given that this whole area now, so it says this is A and this is where it reaches point B, and it says sketch a speed time. I've done that. Given that AB is 526, yeah, thank you. Filming now. I've got my assistant to bring me a cup of tea. That's Miss McDonough. So let's put that, drop some dotted lines down there. That's how important I am. People make me cups of tea when I'm in school. So this whole area is 526. There we go. I'm looking at it on the screen. I've got it on my computer on in front of me as well. So the whole area is 526. And remember from our lessons on mechanics that the displacement, the distance travelled is the area underneath these graphs of velocity time graphs. So this is all to 526 meters. Okay. So if I put in 526 on here. So part B, we've got to work out this velocity here. So if I dot across, yeah, that's the velocity that we're trying to find that it decelerates to. Okay. Well, first of all, area under graph, 25 times 10, because this bit is a rectangle, is 250. Okay. So if I take 250 off this, I'm left with 276. So that means that this area here, let's get rid of that now, the whole, I've put S for displacement is 526 meters, that's all of it. This area here is 250. So this area here is 276, okay? And because the two add together to make this. And this is made up of a trapezium and a little rectangle here, okay? So an area A and an area B. Okay, so the area of A is, because it's a trapezium, these are your two parallel sides, that distance is 25. So the area of a, let's do it in blue, it'll stand out better on here. The area of a trapezium is A plus B divided by 2 times H, isn't it? That's the area of a trapezium, and the area of a rectangle is length times width. Okay, well, that distance is 25 and that distance is V here. So this is 25 plus V divided by 2 times 8, because it's 8 seconds. There we go. Plus length times width, and that is 12 times V. So 12V. Okay, so this rectangle has an area of 12v, 12 being that distance and v being the width of the box. Okay, and then just simplifying all of this, well, 2 and 8 makes 4, so that's 100. So if we do 8 divided by 2 is 4, so instead of using an 8 we're going to use a 4, times in this bracket out, we get 100 plus 4v plus 12v is equal to 276. And so we've got 16v is equal to 270, no, 16 is 176, I've just got an email, taking 100 off both sides, and then if I get my calculator and do 176 divided, that's going to go nice, isn't it? 16 is 11, so the velocity is 11 meters per second to the minus 1. Okay, and the last one, the deceleration. Well, the deceleration is just the there's a few ways of doing that. We can use v equals u plus at. We could use equations of motion. Okay, and just look at this leg. So the initial velocity was 25, and the velocity that it reaches here is 11. Okay, plus the acceleration, which we don't know, and it took us how long? It took us 8 seconds. Oops. Okay, so we can just use v equals u plus at and just look at this little leg of the journey, can't we? We're starting at 25, becoming 11 over 8 seconds, and then if we rearrange that now, you've got 11 take away 25, which is minus 14, is equal to 8a, so minus 14 divided by 8 is equal to a. You can see the minus, it tells us that it's a deceleration, so 14 divided by 8, is that 1.75? It is. So the acceleration is 1.75. It's actually a deceleration, isn't it, of 1.75 meters per second squared. Okay, you could just do the gradient, you know, y over x, so, and again you end up with a 14 over 8. The whole thing is 25. So take off your 11 means that distance there is 14 and that distance is 8. And y over x is the gradient of that line, isn't it? So 14 divided by 8 is 1.75. And you know that it's a negative slope. Okay, so that's the first one. Where's my board rubber? What have I done with that? Lost my board rubber. Oh, it's over there. Okay, let's get rid of that. Sorry about the state of my graphs. It's much better being in my little office study at home. This one here, really important question. The next one. Watch how I do this, by the way, because this is, again, just checking that that's in shot. It is. Okay, do this a very clever way. This is the most important skill that you're going to learn here. Because once you can do that, you can do, you know, nearly all of mechanics. This is all about resolving forces, and you've got to get good at this. Okay, so let's have a look. First of all, we've got our P, which is there, and we've got a 12 Newton force acting that way. Now I'm going to put some other forces on. I'm going to put a force on acting that way, and that is the tension. Okay, so that's the tension in that rope that's acting up there, you know, attached to the wall up here. Okay, and acting down, it's got a weight. This here is a weight, and it has a weight of mg, mass times gravity. Okay, so there's our diagram, our force diagram, and we're going to draw a better force diagram than that, because to solve any problem in mechanics we need to resolve forces. We want effectively everything to go horizontal and vertical, all the forces to go horizontal and vertical, and once we've done that, it's really easy, you know, to solve problems, because we just go up equals down and left equals right if it's in equilibrium. If it's not in equilibrium and it's moving, we can find the net forces going one way or the other way. Okay, but it's no good something being at an angle. Now I like to look at the angle that it's actually coming from. So I know there's a 20 degrees up there, but I'm going to use this angle here, which would be 70, wouldn't it? Because it's a right angled triangle. So that would be 70 if I create it there. And I'm going to split this tension up into two forces. I'm going to split it up into its components of a horizontal force and a vertical force. And when I draw them, you can see that and draw the right angle, you can see it makes sense. We can split. That's got a bit of pull that way and a bit of pull up. And if we can replace that with a horizontal and vertical, all of our forces are vertical or horizontal, and then the maths is really easy then. Okay? So what you want to do, I mean, I just do this instinctively very quick, and you will too, but if you just need that extra step, this is my I or X direction, isn't it? And that is my J or Y direction. So for the time being, I'm just going to label that force X and that force Y. Now, and this is the hypotenuse here, is the tension. Okay, that's the actual, the full force is going in that direction. That's where it actually is. Okay, but if we split it down into these, if we take these three forces, these three sides of our triangle, X, Y, and T, basic trigonometry now says that the adjacent force, okay, so adjacent is linked with cos, isn't it? The cos of 70 is equal to adjacent over hypotenuse. So the cos of 70 is equal, the adjacent force is X over the hypotenuse, which is T. So if we move the T up there, times both sides by T, we've got X is equal to T cos 70. So we can replace the X force with T cos 70. We can also do the same maths and say the sine of 70 is opposite over hypotenuse. So I could do the sine of 70 is equal to opposite over hypotenuse. Let's just click my mouse to stop this going off my screen. So the sine of 70 is equal to the opposite, which is X over T, and move that T up, so T sine 70 is equal to X. Okay, so now what I always do is I redraw out my force diagram, okay, with my new forces on. So now I don't need to use this slopey force here. I'm going to go 12 newtons acting that way, mg acting that way, straight up. Can you see that I've just slid this y force across because it's acting up on that particle, and that is now the y force. I've used x there, silly me, that's meant to be y, isn't it? What an idiot I am today. Okay, the y force is T sine 70, and this one here, the horizontal force, is T cos 70. So I've just now adjusted this diagram for this diagram, okay? And now I can answer all of these questions really easy. These 7 marks are simple now, okay? And they're simple because now I'm going to go for part A, the tension. Well, I'm going to, this one here, I've got the 12 on this side, so I'll use this tension here. So T cos 70 is equal to 12, just checking that fits into my screen as well. Okay, so that equals that. It's an equilibrium, it's not moving, so left equals right. So T is simply 12 over cos 70. I'll do that on my calculator. 12 divided by the cos of 70 is 35, so T is 35.1 newtons. And up equals down, okay? So B, the weight. The weight, now it doesn't ask for the mass. Sometimes it asks for the mass. If it asks for the mass, you've got to divide by gravity, which is 9.8 at the end. But we just want the weight in newtons, the force. So mg is equal to T sine 70, isn't it? So I've already got T on my calculator screen accurately. So we just times that by sine 70. Times sine 70 and press equals. I get 32.9. Is that right? Yeah. So 32 is actually 33.0, isn't it? When we round it off to 1 decimal place. So the weight is 33.0 newtons. Okay. I'm filming, Mason. I'm filming. Okay. Okay, sorry, I had a student at the door there. All right, so that's that one, and the last one, Thursday. Now this is why I'm doing this video again. This is my second run at it because I'm an idiot. I made a mistake on the first one. Okay, yeah, even the great make mistakes. So that's okay. There we go. So Thursday. So a small ball is projected vertically upwards from a ground level with the speed of u. So we always draw a diagram of this. There it is. And it goes up and it comes down again. There it is. Okay. And it is from the floor, from the ground level. It has an initial velocity of u, but it doesn't tell us what that is. And the ball takes 4 seconds to return to the ground. So t is 0 there, and then it's launched, and t is 4 when it returns back to the ground. Okay. What we always know is we know that at this point here, we might use it. We often do. The velocity is 0 because it sort of instantaneously stops, doesn't it? The velocity goes down to 0 and then it speeds down here. Now this is where you have to be careful, because this is where I made classic schoolboy error. Draw in the space below a velocity time graph to represent the motion of the ball in the first 4 seconds. I'll show you the error I did actually. Okay, I did this, which is wrong. There's my velocity time graph, and I went, and of course I sort of went, well, what's happening? It's starting from u, so it starts from u, so it's starting at, it's launched at a speed, isn't it, of, you know, maybe that's 20 meters per second, we'll find out in a bit. 20 meters per second, and it slows down to 0 and speeds back up to 20. And I did this on my first video. I slows down to 0 and speeds back up to 20. But of course, this leg of the journey, when it's speeding back up to 20 from here to here, is going in the opposite direction, isn't it? And when it's going in the opposite direction, that is a negative velocity. So that's velocity. So this graph here should not be going to there. It should be coming down. It should be a straight line. So this means it's slowing down to 0, and then it's speeding up, okay, to minus u, whatever that tends to be on this line here, okay, and that is t is equal to 4. Now it is a straight line. It is a straight line. You know, it speeds up, it slows down, and then it speeds up. It slows down at 9.8 meters per second. Remember, we're taking acceleration as that, acting that way. So it's slowing down, then it's speeding up at 9.8. Okay, so it is symmetrical, which means that that centre part will be 2 seconds. After 2 seconds, it reaches the highest point there. Okay, so that's our graph. Don't do the V like I did. What a muppet. The maximum height of the ball above the ground in the first 4 seconds is 19.6. Find the value of u. So this point here is 19.6 meters. It tells you that. Okay, the maximum height. So find the value of u. Okay, so I'm just going to go v equals u plus at. We can use that one because we know the time from the, we know it's halfway, so we know it's 2 seconds. The velocity is 0. The initial velocity we don't know. We know that the acceleration is minus 9.8. Okay, and we know it took 2 seconds times 2. And in fact, actually, we've not even sort of used this sort of 19.6. We've just used the time of 2 seconds. So that is minus 19.6. So u is 19.6 meters per second to the minus 1. Okay. I don't think it gave you this when you didn't actually sort of need it, so I don't think it intends you to do it this way. I think it probably is intending you to do something like v squared equals u squared plus 2as, using that formula. Okay, if you use that, v is 0 at the top, And we've got u squared plus 2 times minus 9.8 times 19.6. Okay, and actually, if you do all of that, it's negative. Take it over that side, and then it's positive. At square root it, you'll get 19.6. Okay, that will also work. Okay, but you didn't even need to do that. And there it is. The correct version of the learning timetable form. Okay, so hope you had a good attempt at those questions. Hope you enjoyed them. Okay, over and out.